And now it is my great pleasure to introduce Rana Kaliouby, who is a pioneer in the field of emotional artificial intelligence. She is the CEO of Affectiva, a facial expression recognition company that evolved out of her postdoctoral research at MIT and her doctoral research at the University of Cambridge. She is the author of Girl Decoded. She was named one of America's top 50 women in tech by Forbes. She was named as one of Fortune's 40 under 40 and as a global business pioneer by Bloomberg. And today she will be talking to us about bringing emotional intelligence to technology during COVID-19. Do we have Rana?
I'm here.
Online? Oh, great, there you are. Hi. Fantastic. Hi, Rana.
Hi. Nice to be reconnected. We both were at the Media Lab, not overlapping, yes. But it's great to be reconnected. And thank you everybody for having me. I'm very excited to be here. I actually wanted to start with two thoughts building on Jamie's keynote. So first of all, Jamie, I concur with you and the gobs of research that indicates that journaling can be really helpful. I've been journaling for the past 8 or 9 years now, and it has just been so helpful as I navigate a lot of challenges in my universe. So I highly, highly recommend it to you all. I use an app called Day One, which is awesome because it's multimedia. So you can write, but you can also share videos and not share, but post videos and pictures. So that was thought number one. Thought number two, I couldn't help but think, especially with COVID and with all of us catapulted into this universe where we are interacting and communicating and learning primarily virtually, I just kept thinking, like, what if we partnered and you were able to replicate all of the research you do by analyzing text, but this time you could do it by analyzing all of our facial expressions since we're stuck in front of Zoom and other video conference platforms all the time. So I just think it would be such fascinating data to be able to map that out and kind of tie it with other forms of communication. So I've been on a mission to humanize technology. I grew up in the Middle East and then had the opportunity to move to Cambridge University to do my PhD. And when I got there, it struck me that I was spending more time in front of my computer, pretty much like we are doing today, than I was interacting with any other human being face to face. And that got me thinking. I was like, this computer, this machine is completely oblivious to my emotional and mental state. It has a lot of IQ, a lot of cognitive intelligence, but no emotional intelligence. But I guess even worse, it was like the main conduit of communication I had with my family back home. And I realized that I often felt very lonely and homesick and disconnected. Like, even though we were connected because we were communicating, it was almost like an illusion of a connection. So that got me started thinking, what if computers had emotional intelligence just the way humans do? What if technologies could understand our expressions of emotion, and what kind of applications would that unlock? So that story was over 20 years ago. I'm still on that journey. It's a complicated one. From then on, I joined MIT as a postdoc. My career plan, by the way, at the time was to become faculty. So I was kind of very fixated on that, and I was well on track to become that. But then we realized that we had an opportunity to take our core technology and spin that out in a company and scale it in a way that is sometimes hard to do in academia. And so for me, the tipping point was this realization that, oh my God, I have an opportunity to take something I'm very passionate about and hopefully deploy it at scale. And so that was the story behind spinning Affectiva out. My co-founder is Professor Rosalind Picard, who created the field of affective computing. She coined the term, she wrote the book. And I'm, she's my role model and mentor, and I'm very grateful that we were able to start Affectiva together. So Affectiva's mission is to bring artificial emotional intelligence to our technology. And by doing so, not only reimagine human-machine interfaces, which I imagine a lot of you are very focused on, but also reimagine human-to-human connection and communication. And I wanted to kind of share a few slides as I kind of share some thoughts. So let me jump. I wanted to start with this because I feel like this is probably going to be a very relatable experience. So my book came out in April, on April 21st. And so right in the midst of all of this, we're all trying to, we're all sheltered in place, and we're all trying to figure out what this new normal looks like. And I had to pivot from doing an actual like book tour where I was going to be traveling all over the place for, starting March through May, to kind of trying to be creative and innovative. Like, how do you do a virtual book tour? And we kicked it off with this book launch. It was a Zoom meeting with, 92 participants. And it just hit me that if we were together in person, just the way we would have been at this conference, as a presenter, I would have been able to riff off of the energy in the audience. And we all do that subconsciously all the time when we are in a face-to-face conversation. You kind of gauge the level of interest, you gauge the level of engagement. If people are excited, you kind of build on it. If people are rolling their eyes, you change course, right? And I found that it was really, really hard to do that in an online, virtual environment. Again, pretty much like we are here today. Like, I can't see you all. And I find that really unsettling. And it's particularly unsettling because only a small portion of how we communicate is through language, the actual choice of words we use. A lot of how we communicate is nonverbal. And there's a debate on the exact percent, it doesn't matter, but a lot of how we communicate is distributed across our facial expressions, our gestures. I use a lot of hand gestures. I have to tone it down on Zoom apparently because it's too much. But also our vocal intonation, right? Like, how fast are you speaking? How much energy is in your voice? But all of that disappears when we're communicating online. We have no way of capturing that data and capturing that information. And so I'm on a mission to capture that kind of majority of nonverbal cues, if you like. So how do we do that? We use machine learning. We use a combination of computer vision, deep learning, tons of data to train algorithms to detect these different facial expressions. And we map them into a number of states. Now, if you're familiar with this literature, there's been an obsession with the 6 basic emotions. Even back when I was doing my PhD, I kind of tried to challenge that a little bit. We all know from our daily experiences that it's not just about, oops, must be my Slack. I'm gonna turn that off, apologize. It's not just about the 6 basic emotions: joy, anger, surprise, fear, disgust. What am I missing? Sadness? But there are a lot more expressions that we communicate via our face. Some of them are social signals, like when you pass somebody on the street, and now with face masks, you can just like nod your head or raise your eyebrows. These are social signals. When you raise your eyebrows in that context, it's not surprise, it's hello. So, we've been taking an approach where we kind of recognize the nuances and the complexities of mapping a facial expression to its underlying meaning. And recognizing that sometimes it's an expression of emotion, sometimes it's a social signal, and sometimes it's an expression of a cognitive state. We do a lot of work in the automotive industry where we look at your blinking behavior and your kind of head movement, and it's a signal of fatigue, which is, is that an emotion? It doesn't matter if it's an emotion or not, but it's a very important signal. And we're in the business of trying to capture these signals in a quantitative, robust way. So there's a lot of applications of this technology, and I wanted to kind of share some of these. And again, just to make it interactive, I will. One of the very early kind of applications when we first started the company was to understand how people respond to content. And the content could be anything. It could be an online video ad, it could be a movie trailer, it could be a Netflix show, it could even be educational material. So imagine now when you're watching, asynchronous lectures, could the faculty member get real-time feedback on the level of engagement of their students? So I will show you an example of a Coca-Cola ad that we tested, and then I'll show you the results. And the way this works is, if you are watching this ad, we would ask you to turn your camera on. It's super important to get consent, obviously. If you say yes, camera turns on, and we're able to collect your facial expressions in real time, aggregated anonymously across everybody else that's watched the ad. And then we present that back to the content creator.
Come prima, più di prima, t'amerò. Per la vita, la mia vita ti darò. Sembra un sogno rivederti, accarezzarti. Le tue mani fra le mani stringere ancora. Il mio mondo, tutto il mondo, sei per me. A nessuno voglio bene come a te. Ogni giorno, ogni istante, dolcemente ti dirò come prima, più di prima, t'amerò.
Yeah, mom got there first. So this, again, we're able to capture the moment-by-moment responses people had to this content. And you can see, I think right here, we're just showing the smile responses, the solid line.
Rana, I think we can't see what you're sharing.
Oh, you can't?
No.
Oh no, that's sad. Sorry, I did not share my screen. Shall I play it again?
Yes, please. Thank you.
Better?
The nice thing is we did get to see your facial expression as you were watching it, which actually I thought was actually very interesting. So we got to see what you analyze.
Okay.
But now we'll see the ground truth. Thanks. No, it's actually really interesting. I thought we were supposed to be looking at your face, honestly, but let's see it.
Okay. Well, not really, but that's funny. All right, let's do it this time with the actual content.
Come prima, più di prima, t'amerò. Per la vita, la mia vita ti darò. Sembra un sogno rivederti, accarezzarti. Le tue mani fra le mani stringere ancora. Il mio mondo, tutto il mondo, sei per me. A nessuno voglio bene come a te. Ogni giorno, ogni istante, dolcemente ti dirò come prima, più di prima, t'amerò.
All right, better? Makes more sense. So this ad has been, aired all around the world, and we are able to capture people's moment-by-moment responses, just like you were watching my face, but we're able to capture that data, again, with people's consent. The solid line here shows the first time people saw the ad, and the dotted line, is when they see it the second time, and you're able to see that people actually remember it, right? Like there's a shift in responses, which indicates that there's some kind of memory of the content, which is great. Just by comparison, a lot of the content we test, usually you just see a flat line. It's usually like really boring shampoo ads, no emotional elicitation whatsoever. So we've been able to build these incredible benchmarks for different types of content in different parts of the world. And that ties to actual behavior. So we know it ties to purchase intent, virality, learning outcomes. So it's really interesting data. And we sometimes pair that with self-reported data as well. I mean, Jamie kind of alluded to that. Self-report can be quite can be quite biased, right? But it does tap into an interesting part of the brain that's different from what we're tapping into when we are looking at these kind of subconscious, often visceral facial expressions. So that's one application. And again, we think of this as kind of the space of how do people respond to content, and the content can be anything really. What is really interesting about this too is we're part of this Stereotype Alliance that is trying to push the boundaries in terms of advertising, and especially how a lot of advertising is very stereotypic, and when brands try to push the boundaries, it's hard for them to tell what kind of response they're getting, and this again gets to a very interesting subconscious response. I want to kind of share other examples. As I said, automotive is an area that we're very focused on, and the idea there is to capture both the emotional and cognitive states of drivers and other occupants in the vehicle. When we first started doing this work, we had no idea if people even exhibited any facial expressions when they're in the car. So we got out and collected naturalistic data. And we have permission to share some of these videos, and I wanted to show you a few examples. Hopefully they'll play well on Zoom. So this is an example of a dad. You can see his daughter in the background. This video actually goes on for a good 5 minutes. He's clearly asleep. This is kind of the extreme level of drowsiness. There's multiple levels of drowsiness, and this is the extreme example. But it's actually quite easy to detect using computer vision machine learning. His eyes are closed, and his mouth is open, so we can detect kind of expressions of yawning, which are typical in the early onset of drowsiness. So that's an example where if the technology was able to detect that in real time, the car can hopefully respond in real time and keep him and his family and others on the road safer. Here's another example. So she's driving, she's got a phone in her hand. Oh, she's got 2 phones in her hand. It's pretty scary. So she's very distracted. Her eyes are off the road, her hands are off the wheel. And this is another example where we could detect this quite easily using technology. We're now able to, and I'll just show you some kind of examples of what we're able to detect. Yawning, eye closure, head, your head pose, which becomes really important. Doing this in a car is brutal because we have to obviously account for a wide range of lighting conditions. We're focused on the other occupants in the vehicle too, which is really interesting because the car can respond in very different ways. And I just want to fast forward a little bit and hopefully find examples where we're detecting other objects in the vehicle too. So if you're texting while driving, we can hopefully see your phone as well, triangulate the 2 pieces of information and flag that as an extreme case of distraction. So I'll stop here. But the idea is that now you have these in-cabin sensors, right? Cameras, but also microphones, and you can combine these different modalities of information to really understand what is happening inside the vehicle, and then you can have the car respond in real time, reimagining both kind of road safety, but also even personalizing the riding and the driving experience. So a lot of innovation happening in that space. And then, of course, we kind of talked about that, right? Like, what if we are, again, with people's permission. I'll just play this for a few seconds, but basically we're tracking everybody's expressions, and you're able to aggregate that and get a sense of how engaged people are, how positive or negative are people's experiences. And from a technology standpoint, the technology's there. We kind of just need partnerships with, with organizations that have this data and are willing to share it. What I find really potentially fascinating about this is, imagine if you compare that with people's, self-reported levels of emotions, but perhaps more importantly, especially in organizations, maybe you compare that or combine that to understand loyalty. Motivation, is my team motivated or not? Are they energized or not? Are they anxious? So I think there are productivity, right? You could probably tie a lot of this to productivity as well. So I'm kind of really intrigued in the relationship between these team dynamics, and then tying it back to KPIs that we all care about. And you can do this in the context, obviously, of an organization, or of course, it could be a presenter, kind of a lecturer or a speaker context as well. And I do believe that if we found like an interesting way to visualize this information, it could be a conduit for creating more of a shared experience.
Right. So.
And then learning, of course, I want to just share this video of my daughter from years ago taking math on Khan Academy. And I did take her permission to record this video. And I do have to say, math is not her strong suit. It still isn't. She's a senior in high school now. But you can see, again, all of these different expressions. Like our hypothesis going into this is that there's no other human, in this interaction. She may not have any expressions, but she actually did. And if you're able to capture all of this information, these online learning systems can adapt in real time, or could at least, when she's like really bummed, maybe it can intervene and kind of cheer her on, or provide a little bit of support the way an awesome teacher would do in a live classroom. Yeah, it's not working. 12 divided by 3, really hard. Struggling with that, and you could see that. You could see her thinking, you could see her being frustrated. Yay, awesome. And then just to kind of wrap it up, one of the areas that we first explored for this technology is in mental health. When you go into a doctor's office, they don't ask you what is your blood pressure, they just measure it. But in mental health, the gold standard is still a survey on a scale from 1 to 10. How depressed are you? How suicidal are you? And this data can be quite subjective and unreliable. And so with this kind of technology, be it facial expressions, vocal intonations, physiological signals, you can really create a baseline for the individual and track if the individual kind of diverges from that baseline, and flag that to a family member or a doctor. So there's a lot of innovation that can happen there. And again, I feel like the core technology's there. It's just a matter of figuring out how to do that at scale. I'll also share this example in the autism space. When Roz and I first started working together at MIT, it was the very first application we explored. And now we're able to partner with a company called BrainPower that uses Google Glass and our technology to help kids on the autism spectrum. And I'll just show you a really powerful video.
That's great.
Of that.
8-year-old Matthew Krieger has been diagnosed with autism.
A lot of the trouble he gets into with other kids is he thinks he's funny and doesn't read at all that he's not, or that they're annoyed or angry.
Matthew's mother, Laura, signed him up for a clinical trial being conducted by Ned Sahin.
I want to know what's going on inside the brain of someone with autism. And it turns out parents want to know that too.
You get points for looking for a while, and then even for looking away and then looking back.
Sahin's company BrainPower uses Affectiva software in programs Matthew sees through Google Glass. These games are trying to help him understand how facial expressions correspond to emotions and learn social cues.
One of the key life skills is understanding the emotions of others. And another is looking in their direction when they're speaking.
Looking at your mom, and while it's green, you're getting points. When it starts to get orange and red, you'll slow down with the points.
Am I looking at you?
You are looking at me.
Just a few minutes later, the difference in Matthew's gaze overwhelmed his mother.
I'm gonna cry.
Why?
Because when you look at me, it makes me think we haven't really before. Because you're looking at me differently.
So there's a lot of potential. This team is now deploying about 400 of these Google Glasses deploying 400 of these Google Glasses in a number of homes with kids on the autism spectrum, we already know that when the kids have the glasses on, we do see an improvement in the amount of face and eye gaze contact that they're doing. And we're also seeing an improvement in their ability to recognize and identify these different facial expressions. It's unclear though, whether this generalizes when the kids don't have the glasses on. But basically the question is this a prosthetic device or is it a learning tool? And it's unclear as of now. You know what it is, but I do, you know, I often get asked, you know, at this point when we're talking about this technology, people's brains often go to like really dark scenarios where this technology is used to spy on people. It's used for security and surveillance and profiling. And I think that we can't ignore that. That is an absolute potential abuse of this technology. But I also think of the potential for good and, you know, around mental health, around autism, around road safety and many, many other areas. And I really kind of, I guess, the call to action here is ensure that we're spending our energy and our mind share on these right applications. For example, us as a, you know, at Affectiva, we turn down millions and millions of dollars of business around surveillance and security. We just literally just turn it away. And it's really part of our core values. And we're trying to advocate that, you know, beyond the Affectiva walls. So we're part of the Partnership on AI Consortium, where we collaborate with other tech companies, as well as civil liberty organizations like Amnesty International and ACLU, to make sure that we think through the unintended consequences of these technologies and guard against them. And I, you know, even though we're a very small team, I feel like that's responsible leadership, and we owe it to ourselves and our communities that we advocate for these kind of technology and demystify it. It's one reason why I wrote the book. I really feel like, I mean, we are all kind of on the forefront of all of this, but a lot of people really don't understand how this technology works. And it's our job to demystify it and make it accessible so that the average consumer can be part of the conversation and they can say, okay, I'm okay with this, but I'm not okay with that. And I think this is how we end up with companies committed to ethical development and deployment of AI. The final kind of note on this is, you know, I often get asked, I'm sure a lot of you do too, you know, are robots going to take over humanity and are we doomed? And I'm like, I'm not concerned about the robots. I'm concerned about building bias into our AI systems accidentally. That's like the imminent issue of AI today, in my opinion. And that's done by, you know, usually unintentionally building very skewed databases and data sets that we use to train these algorithms. And I think at the core of all of this is lack of diversity and inclusive voices in the teams that develop these technologies. So I'm very, very passionate about ensuring that our teams, you know, developing these technologies are diverse, not just in terms of age, not just in terms of ethnicity, but in terms of background and experiences. And yeah, and so again, if you're out there, make sure your voice is being heard in the equation. And yeah, I guess final thought. Yes, we're in the business of building artificial intelligence, but it's let's put the human first. So human first. Thank you.
Great. I just want to give a applause, and that's a very amazing talk by both of you. And apologies first to all the attendees who's got a lot of issues logging into Wova, and I'm glad that you all can join us on Zoom, and please post your questions on the Zoom chat. So